Okay, hello everyone. Today we'll be learning how to conduct another test about another experiment of our transportation engineering session 1, that is the experiment regarding aggregate size. In the last class we have identified 3 tests regarding this, of which 2 tests were discussed. One was the flakiness index. If I say one flakiness index, and another one is the elongation index. Okay, so I think by this time you have known about these 2 tests, so I don't want to discuss these 2 again. So we'll be today learning the remaining 1 test, that is the determination of angularity number. So angularity, another measurement for aggregate size and particularly the shape. You can see aggregate size and shape. So this one is referring to the angularity of any particle. So today we'll be learning the experiment number 6, which is the determination of angularity number or AN. So what is angularity number? Angularity number is a determiner of the angularity of the particles. So whether the particles are rounded or angular in shape, this is the identifier of this shape. So from this number you can imagine about the particle sizes or shapes, if I can say. So that's why this number is important. To be more specific, if I say it is calculated from the proportion of voids, proportion of voids in a sample of aggregate, after compaction. So this is the actual definition for this angularity number. So it is determined from the proportion of voids in a sample of aggregate after compaction, and this property is actually used. We will be learning how to determine this proportion, this angularity number, the formula. But before that, this angularity number is used mainly in the design of mixed proportion. So mixed proportion design and research purpose we use this angularity number, the AN. Okay, this angularity number can be range from 0 to 12. So if you think about the rounded particle, the perfectly round particle, so what is the benefit of the perfectly round particle? So it will be the workable in manner. So it will provide good workability for the concrete mix. And in this case, you will see there will be some void, and if these all aggregates are perfectly round aggregate, it shows that from analysis or experiments, this void will be minimum 33%. That is the minimum void can be obtained. For what? Perfectly rounded aggregates. So perfectly rounded aggregate will be getting 33% of void. But what will be the amount of void in case of if it is not rounded in manner? So if it is angular in manner, if we see say particles are like this, which is actually we see in our real life incidents. Okay, so this kind of particles might be there. So this kind of particles will be there. So in that case, you will see in this collection of aggregate, we will see that it will give more than 33% of void um, in this container of the aggregate, and the additional percentage of void from 33% is called the angularity number. That is if the angularity number is 42, then the angularity number is, if it is 10, it will indicate that the actual void is 43%. So that is the additional void, in addition, the void addition in addition to 33% and of this sample will be denoted as the angularity number. So the additionals, and this range is, we have said 10 to 12%. That means the void can be starting from 33% up to 45%. So 33% or close to 33% will be indicating perfectly rounded aggregates, whereas close to 45% will be indicating this uneven and angular size of the aggregates. So it will give more and more amount of void there. So one might ask a question that why this angular aggregate will generate increased void in the sample or container, although it should be less void in size. Okay, to give example, I am drawing a cell like this. Okay, so if any case you think that this is the orientation of the angular particle, so what might be the maximum void size? So maximum void might be, if you think that okay, maybe this void will be up to 50%, just because greater than 50% might be indicating that it will be keeping some blank space over there. But no, it is not possible. If all the aggregates are in contact with each other, then what is the possible void? So if it is, you think this might generate 50% of void, but actually it will not, just because the aggregates will not be in this orientation, just because we have defined that these aggregates must be compacted. The compaction procedure we will be learning afterwards, but this compaction, you see, we have said angularity number indicates the proportion of the voids in a sample of aggregate after compaction. So compaction must be applied while calculating. So if you apply compaction over this sample, what will happen? What do you think? If we apply compaction over this, it will be changed like this. So it will be, in any case, somehow it will be converted to this one. So void will be reduced. So in any case, if the angularity is such angularity exists, so that it never, it cannot be compacted anyway, the void cannot be reduced. So the maximum void possible, if the angularity maximum is um, existing, so it will be giving 45% up to maximum. And if it is rounded particle, if you try to compact this, it will be, the orientation of the aggregates will be like this, and therefore the minimum void will be resulting. And the study shows that this will give 33%, it will give 33% of void remaining. And although the particle size, all the particle size are not same, all the particle size will never be same. So whatever it is, but actually 33% void minimum will be governed for the perfectly rounded aggregate, and for the angular it will be 45%. Again, you might say that, okay, if the angular aggregates will not be like this, keeping the void below 45%, then why not it will be less than 33%, or close to 33%? Why not? Just because you again cannot expect, um, if this is the container, again you cannot expect the aggregates will be like this. If it is an angular aggregate, you cannot expect, okay, angular aggregates will be oriented like this, or like this. So you cannot expect that the angular aggregates will be oriented in this manner, just because it is not like Legos. As you know, it is not like Legos that one side of this will be connected to another portion like this, so that no voids will be remaining. So no, this is not possible, just because whenever you will be applying compaction, you only can reduce size, just but not into this kind of shape, or less than this kind of shape. This is not possible. You will have different size of aggregates, different angularity of aggregates, but you will not achieve the void like this, or less than this, in such a manner. So it will be looking like Legos, that all the ends will be connected to the another aggregate. Rather, whenever you will be blending these mixes into the blending into the mix into container, or before placing it for bituminous mix on the roadway, you will find it less workable, and there will be generating more and more voids. So never you can expect this. It will be only possible if you place one by one aggregates, and that is almost impossible. And even then, you will not be achieving it more than less than 33%, or neither you will be getting close to 33% even either. Okay, so that's why for the angular aggregates there will be less possibilities, so no possibility. Always you will be getting the value of the angular aggregates close to 45%, whereas the perfectly rounded aggregates you will be getting tending to the void to be close to 33% in a manner. So that's why we say that angularity number will be from 10 to 12. So if it is 0 to 12, so if it is 0, that will be indicating a more rounded shape, or close to 0, more rounded shape of the aggregate. And if it is 12, the sample size, which will be indicating more angular in shape. Okay, so we have said about the concrete mix. If you find it close to 0%, it will be perfect for what? Perfect for concrete, or the rigid pavement design, if you say. And if you get it close to 12%, what will happen if these are angular in manner? Angular particle will provide, in case of bituminous mix, it will give you um, interlocking. So in case of bituminous mix, it will ensure angularity will be ensuring you the interlocking of the aggregate. So that means there will be less probability of the aggregate in bituminous mix. So if it is a bituminous pavement and you see numerous this kind of aggregates are there over this bituminous, within this bituminous pavement, and bitumen binder will be used to adjust this thing, so interlocking will be strong, so it will ensure greater interlocking properties in case of bituminous, that is the flexible pavement. So flexible pavements, it will be giving more interlocking properties, just because all these are angular, will be stick to each other, whereas if it were rounded aggregate, in case of bituminous means, there will be more probability of creating disintegration within the road, and also the interlocking one with another will not be um, as as good as we can expect. So that's why angularity, if you get angularity close to 12, then you will be indicating it as perfect or good for flexible pavement, recommending it good for flexible pavement. Whereas if you get less angularity number of the aggregate in your experiment after conducting the test, you will be referring in discussion that it is suitable for concrete, just because it will ensure higher um, workability, so that's why always try to give overview based on the result we are getting. So and now we will be moving into the experimental procedure for this test. We'll see how to approach for this particular test. So while starting this test, I need to um, say something about this angularity number again, that in this case this angularity number, while determining, will be using an an uncommon base shift to that of the previous experiments, and that is starting from 20 millimeter up to 5 millimeter. So how 20 millimeter passing 20 millimeter, then 14 millimeter, then we'll be taking 10 millimeter, then 6.3 millimeter, and finally 5 millimeter. So this British standard shifts will be using for this particular experiment. So it indicates that our sample will be passing through this one and retaining on this one. So that will be our sample. In case, okay, our cylinder size for this case, we'll be using a cylinder. The cylinder will have volume approximately 0.003 meter cube of volume. So in case in your test, if you are conducting with greater than 20 millimeter, if you are using greater than 20 millimeter particles as well, in that case this British standard will not be taking the liabilities, rather than they are recommending you to use they are accepting this thing actually, and they are recommending you to use greater than this volume if you are taking the sample greater than 20 millimeter. But they are giving a standard which is almost equals to 0.003 meter cube of volume of cylinder, in which the test will be conducted, and it will be passing through 20 and retaining on 5. In case you are using greater than 20 millimeter, then use greater size of volume which is recommended by them. But in case if the particle size or aggregate you are using which is less than 5 millimeter, in that case you will not have to lower the volume of the cylinder further. You can use the same cylinder for that. Okay, so the cylinder will have the volume of 0.003 meter cube approximately, and you will be needing a balance, as you know, for as we can use for all of other experiments. And obviously there will be some exception in the aggregate drying procedure in this case. If you can remember, so far all the tests we have conducted, we have used the room temperature, and we have kept it in room temperature. And if you see, all of those experiments, if I can remember, were cooled in the room temperature before conducting the test, and heated using it was heated actually it was dried using heater, using by heating, sorry, dried by heating in all other experiments. But for this particular experiment, it is giving you the direction to dry this using oven dry. Why? As we will be using water in this container, and it is related to void, so oven dry will be giving the actual void, just because the simply drying by heating will just remove the water from the surface, but there are force within the aggregate, this aggregate, which might not be dried using just if it is dried using heating. So as it is, the test is related to void, that's why to make it oven dry, we will be using the oven to dry this. And for angularity number, this should be dried in 105 plus minus 5 degrees centigrade of temperature, and again for at least 24 hours, in up to 24 hours. And while cooling down, it was cooled into room temperature, whereas this oven dry sample will be cooled before testing in airtight containers. Airtight container. So just because of what? So that no moisture is absorbed by these particles, this aggregate, so that you are not getting the confusing void amount. To get actual void, calculate the actual void of the sample, we need this procedure. So this is an exception for this test, as it is related to void. And obviously you will be needing tamping rod, metal tamping rod, balance, metal scope, etc., as we use generally for all other tests regarding aggregate. So this is the sample preparation. Okay, so now we will be learning the method how to conduct this test. The angularity number will be learning. So first of all, we'll be taking the container, the container should also be dry. The container should not be wet in any case. So if we take the void container, then we'll be filling this container with the aggregates in 3 layers here, in 3 layers. So first of all, one third will be, so 1/3 will be first of all filled. Then using the tamping rod, if I give the specification, although not necessary for you to memorize, the tamping rod will have, the tamping rod will be will have 16 millimeter of diameter. So diameter of this tamping rod will be 16 millimeter, and it will be 600 millimeter long. So using this tamping rod, what you will do, this circular cross section, this cylindrical tamping rod, we will be using this tamping rod, in this to compact this. So how many tamping should be given? So you will be tamping 100 times. For angularity number test, it is guided for 100 times tamping for each layer. And so see how much sensitive this is, and this should be from 50 millimeter above. So from the top of the surface 50 millimeter above, or 2 inch, we can say, from 50 millimeter above, you will be, how to tamp this thing, you will be just releasing this from hand. Don't put additional pressure on this, just release from hand, so that from this gravity force, it will it will be automatically giving its own weight into the aggregate as compaction, and you will be evenly distributing this tamping rod over the surface top of the surface of the aggregate 100 times each layer. Then again fill this up to again 1/3, then again give tamping rod, and finally again 1/3. Again you will be using tamping rod, each time 50 millimeter from the top surface of that particular layer. You will be using the tamping rod 100 times. So total 300 times we will be using this tamping rod. And why this is important? Just because this is obviously related to the void. So in any case, the compaction, this must be maintained, very sensitive thing, this, just because if you give just one additional time of blow, or if you just put additional pressure from your hand, the result might vary up to a long up to with a long range. So that's why, and the void is very much sensitive thing, as you know. So if you give greater compaction, then densification might be happened. So that's why this procedure we must maintain in all other cases as well, all other experiments as well, but especially for this case we should be more and more sensitive to the test while conducting, just because small additional load or change in the force might vary or might influence the result of our test in this case. So that's why you must be careful while giving pressure or load over the sample, and make the level of this particular cylinder sample. So we will be, after that we'll be taking the weight. Obviously you will be taking weight of the bare cylinder, the empty cylinder. Then after compacting 3 layers, you will be taking the weight of the cylinder plus aggregate, and after that you will be totally removing all the aggregates from the cylinder. Okay, another thing I need to mention, that whether your compaction was correct or not, the compaction you have applied on the aggregate, whether it was influenced by external factors or not, we need to check this. That's why this standard also mentions that you need to prepare these samples 3 times. So 3 times you will be using the same aggregate sample. From same aggregate sample you will be taking 3 measurements. First of all, fill this cylinder with those aggregate, then take all, and then weight this thing as w1, say this is w1. Then again weight this as w2 with another, again taking the sample. Following the same procedure you will be getting w2, and for the third time again emptying this cylinder, and again filling it up to 3 layers, and again taking the measurement, it will be w3. So all these 3 tests you will be taking the weight as rounded gram value, as I have said for the 2 tests in the past week, that we will be getting the rounded gram value. So in other words, I can say the value will be accurate up to this value. So if we are taking kg, or in other words you will be, I can say I am taking rounded gram value. Rounded gram value I can also say. So don't use fraction for gram, and the balance is also, you will not be giving you any fraction in gram value, rather you will be getting fraction up to 3 decimal might be, if it is showing in kg. So automatically you will be getting the rounded gram value. So 3 measurements will be getting, and mean of these 3 will be taken. Say ws I am indicating. So if it is ws, it will be mean of these three. So 3 times you will be measuring weight, and you will be taking mean as this ws. So, and while taking this measurement w1, w2, w3, before getting the mean of these 3, you will be checking whether any one of these weight is differing with any one of other. So you will be checking all these 3 individually, you can check. So whether any one of these is differing with more than 25 gram, plus minus 25. Okay, so if it is plus minus 25 gram, within 25 gram or not. So for example, if I say the one is, you have got one as 6535, one you have got 6522, and again one another you have got 65 you say 42, sorry 40 say 50, I say 6550. So in that case what will happen? So w1, w3 and w2 and w3, 3 values we are getting. So actually we will not be comparing these 3 with these other 3, rather we will be comparing this with mean. Sorry, we will be calculating mean first of these 3. So if we get the mean of these 3, 6535 plus 6522 plus 6550, then divided by 3, you will be getting the value as, obviously you will be getting fraction. You are likely to get fraction. In this case the mean will be 6535 6535.67. So this is the mean. So you will be checking whether any one of these is exceeding the difference with this one more than 25 gram or not. So this with this difference is very less, that is 0.67, it's okay. The difference with this with that is again, you will be watching that the difference will be again very less, maybe approximately 12 point something. So again this will be okay, I think 12 or 13 point something, 6 7 maybe. So it will be again okay, just because it is not exceeding 25. And in case of this one is as well, it is also not exceeding 25 gram. But in any case, if those one of these values, after taking the mean, you see that the difference with the mean to any of this one is more than 25 gram, then you will have to reconduct and re-prepare three sample again like this, and waiting three until you are getting not the difference with again this next three new test, new sample weight, the mean you will be getting again, until you are not getting this value range within 25 gram, you need to reconduct this. So this again, this standard with this particular restriction is ensuring that you haven't given any additional stress or additional load in this particular sample. So if you are giving external force or influencing this cylinder with hand, the aggregates you are, then in that case it will be giving you a variation more than 25 gram, and that's why you will be uh, getting this indication, so that you will have to reconduct this up to 3 samples again to get the mean. And while you are getting mean, I've said that this value may be WS, and what you will do then, if you find that is satisfactory, that is within 25 gram, then you will empty the cylinder again. The aggregates, all the aggregates will be removed. Then the totally empty cylinder, you will be filling this cylinder with water. So you will be totally filling this cylinder with water and again weighting the weight after subtracting the value from the empty cylinder, you'll be getting the weight of water only. And from these two value, and we need to know what another thing we need to know, that is the specific gravity of the aggregate. So there is a particular procedure to determine specific gravity of the aggregate sample we are using. So we need to calculate the specific gravity of aggregate. To use this specific gravity G within the equation, the formula of angularity, to calculate in the angularity number. Okay, so if it is G, say I said GS, okay, in that case how to calculate the angularity number? So the angularity number formula is 67 minus WS WW multiplied by G into 100. So how we have found this particular equation? That is the question. So I am just in short, I am showing you how we have found this particular formula. Okay, first of all we will be focusing on the void. I am just showing this just because we need to, maybe in quiz I can give you the derivation of this angularity number formula, how we are getting this value, then you need to describe and illustrate all these things. I am not showing all the I'm just exploring, trying to explore this thing, how we have got this formula. You need to write in details. If in quiz I am asking you to write or derive. So let's think about the empty cylinder. If it is the empty cylinder, this cylinder, if it is filled up with aggregates and compacted, obviously after compacted you are getting the aggregate. This aggregate will have a volume of Vs. All these aggregates, this combination of aggregates will have a volume of Vs. Okay, obviously I'm talking about 3. So this sample is representing three samples we have used. We have said about it earlier. So think about it, this one cylinder, this one combination of aggregate is representative of 3 sample we have discussed. Okay, so this Vs is representing actually the 3 samples mean volume of solid or this aggregate. So this 3 solid portion of volume, how to determine? So you cannot determine the volume of solid. How you will determine this all the aggregate volume in combined manner? So to do that we need this volume formula. You know what is the formula? The weight of this aggregate, if it is Ws, then it will be equals to Vs, that is the volume of this aggregate, and if you know the unit weight of this aggregate, and in turns if you know the specific gravity, that is Gs, then we can say this is equals to Vs multiplied by Gs multiplied by unit weight of water, that is unit weight of water, as you know. Okay, so from there you will be getting volume. This volume you can calculate indirectly as Ws divided by Gs to gamma. Okay, so we are getting the volume of solid. So what will be the percent of void, percent of field? First of all, say first of percent of field void, field space. So that will be total space and the field space. Okay, so if it is the total volume of the container, we know that 0.003 meter cube. So with respect to this, the amount of volume which is filled by this aggregate, that is the field space or volume. Space means volume, space means volume. Okay, now after you are filling the total cylinder, if you have filled this total cylinder using the water, that is totally filled up with water, you have got the weight as WW. So I need to know this total volume, exact volume of cylinder. Then what we will do, the volume of water, as it is filled up with water totally, the volume of water will be WW into gamma W, as you know. So sorry, WW will be equals to volume of water into gamma W. So from there you can calculate VW equals to WW divided by gamma W. So this volume of water, actually the total volume, the total space within the cylinder, the same cylinder as we have used. So this is actually VW, and this field space actually indicating this Vs, all the filled up space, so that is Vs. So the percent of field space will be nothing but percent of field space will be field volume, if we say, will be nothing but Vs divided by Vw, and obviously if you are getting it in 100% percentage, you need to multiply this total value with 100, and that's why if we are multiplying this with 100 multiplied by this, so we'll be multiplying this with 100. So to multiply this, we'll be now let's put the values here. What is the Vs? Vs is, as we know, that this one, okay, this one, and Vw is this one. So we can put the values here. The Vs will be Ws divided by Gs gamma W, and this is multiplied by 100, and this is WW divided by gamma W. So we can reform this equation as Ws, sorry, it will be WW, will be WW. So we can reform this will be cancelled out, that's why we'll get Ws by WW into Gs multiplied by 100. So this is actually the percent of field volume. So we need to calculate what? Percent of void and angularity afterwards. So percent void will be what? So if it is the field volume, then void will be 100 minus field, percent of field. So that's why it will be 100 minus Ws multiplied by 100 WWGs. So this is the percent of void. And again, we now need to calculate the angularity number. So angularity number, by definition, we know what? In addition to 33%, the void in addition to 33% is known as the angularity number, as we have discussed earlier. So that's why we need to subtract percent of void minus 33, as we are will be getting the angularity as the in addition to 33% void. So that's why this will be the formula. So if we put the values here, Ws into 100 WW into Gs minus 33, so you will be getting the value as 67 minus Ws, the 100 WW multiplied by Gs, and this is nothing but the formula we have written here, as you can see, angularity. So that's how we can get this value. And if you put this value, this was actually the mean of 3 tests which were not exceeding 25 gram range, each from the mean value, each of 3 samples with the mean value, each of the is not exceeding 25 gram. And while taking mean will be fraction, but individual 3 samples will be giving you rounded gram, and mean might be the fraction value. And weight of water, you will be measuring the weight of water only once. You need not to measure the water 3 times, I think. So finally you'll be getting a value which will be ranging from 0 to 12, and obviously if you are getting fraction you will be rounding to nearest whole number. So again I'm saying, if it is your quiz we will be watching, this is very simple formula, if I just give you the data you can easily calculate, but what I will be uh, pointing out that whether you have rounded it properly or not. If you are writing just okay 9 point something 7, then you will be getting 0. I will not be giving you marks. So just because what you don't know how to round it, how to report it, so while reporting you will have to round it to whole number. For this particular experiment, the angularity number, you should remember it again. Okay, so this is all about angularity number. I need to talk something additionally about the discussions, as we have started all the discussion of theoretical portions, but we haven't started any experiments yet. But I need to give you some direction. While writing discussions in transportation engineering sessional, we will be recommending you, whenever you will be writing the discussions, will be pointing out like number one, the value. You will be writing which thing. You will not be writing the measurement was wrong, the orientation of the machine was something, some problem or malfunction in this machine. We think not like that. You will be you will be thinking about the value we have found. This is the finalized value, and this is actually the correct value, just according to the standard. And the value, the indication of the value, say we have got 9 of angularity number, so you'll be writing okay, it will provide good interlocking property, good interlocking property, say for example, good interlocking property, you say, for what, for flexible pavements, say. Okay, so flexible pavements. Then 2, you will be get, it will provide uh, less workable concrete blend, concrete blend. Okay, so this kind of things you need to write on number 3. So additional things, we encourage to write additional things, but whatever you write in addition to the general common sense we are discussing in the class, you should be adding some reference. So you will have to add references to that, whatever you are writing. Say you have got a property like, okay, if you are using greater if it is greater than 9 angularity number, some researcher, any research is providing you an information that if it is greater than 9, it is very good for highway construction. Say for example, highway construction of flexible pavement, obviously. So flexible, this thing you have written there, but where is the source? That if it is greater than 9 and you have obtained greater than or equals to 9, and you have obtained 9, then it is good for highway construction. Is there any specific guideline? In generalized view, we cannot find any. So if you are writing this, you must need to add some reference. You are writing one, and in the um, after all discussions you will be writing number 1 reference. Then you write the details about retrieved for retrieved from this website on dated this, or something like this. Or you can also add the reference in this first bracket after whenever you have completed this thing, that obtained from there. So both these two ways you can use. One is that you can use in each point bullet you will be writing the indication discussions, and then within the bracket you will be mentioning the source, um, or you can also give reference number and finally provide the reference if you give additional information. And obviously we will be giving obviously whom we will be giving more marks, or out of 10 will be giving more than 9, 9.5 or 10, whom will be finding that you are using this additional reference, so that you are thinking about it, you are searching for the indication, so that we'll be giving. Other than that, the common generalized points will be written by everyone within. That's why you should be adding the reference we recommend, and it will be obviously enhancing your knowledge as well. One additional thing I might be mentioning, should be mentioning about this angularity number, which is that um, this a angularity number is also um, indicating the stability of the mixture. You will be learning about it. Just I am, I am just giving you the introduction. Stability of mixture. Don't think this is a generalized term. Mixed stability. In mixed design, you will be learning. In mixed design, there is a term we use, stability, and it has a specific definition, also mathematical measurement as well. So stability is a term in mixed design we use. So while this angularity number of the aggregates will affect the stability in the mixed design. So due to the angularity number, due to the change in angularity number of the sample aggregate, it will be influencing on stability. So you can also search for this, what will be the impact on stability for angularity number, and based on that you can also add references. So however, this is all about today's lecture. From the next class we are expecting to start the experiments regarding bitumen. So I hope you have enjoyed. Thank you.